Today we're going to look at special forms of the conditional. I entitled the video Cousins of the Conditional because there are three special conditionals that come out of every conditional, and I'd like to show you what they are. Suppose the original conditional is, if Charlie is a horse, then Charlie has four legs. So here, the antecedent is Charlie is a horse, and the consequent is Charlie has four legs. Now, one conditional that we can form is to flip the antecedent and consequent and write, if Charlie has four legs, then Charlie is a horse. Okay, when we flip the conditional and the antecedent becomes a consequent and vice versa, we call this the converse of the conditional. So let me just write that down for you. It's like the commutative property. So this is if Q, then P. Whereas the original one was if P, then Q. All right. Now, the next two conditionals are formed by negating pieces of the original conditional. The first one is called the inverse. And the next one is called the contrapositive, which we consider the contrapositive the most important here in mathematics, especially when it comes to proofs. So the inverse is formed by taking the original conditional and negating the consequent and negating the consequent and antecedent. So we have if Charlie is not a horse, and again I'm putting the word not because I have to negate. So if Charlie is not a horse, then Charlie does not have four legs. And here again we negate the antecedent and consequent, and we write this as if not P, then not Q. Okay? All right. And then finally, what do you think the contrapositive would be? Well, there's only one left. That's just negating the consequent and the antecedent and flipping it. So we have, let me just write this in the right color. If Charlie does not have four legs, then Charlie is not a horse. And we represent that as if not Q, then not P. And notice that the contrapositive can be found in other ways. We don't have to go back to the original. The contrapositive can be found in terms of its converse and inverse. Can you see how? The contrapositive is the converse of the inverse. So if you take the converse if you take the inverse and flip it, you get the contrapositive. It's also the inverse of the converse. We take the converse and negate each piece. So again, we've got the original conditional. We we flip the consequent and antecedent. That's the converse. Okay. The next two involve negations. So in the inverse, we just take the original conditional and negate each piece. And the contrapositive is taking the original conditional, flipping and negating each piece. All right, let's summarize on the next page. So it all depends on what the original conditional is, but we'll make it very basic. If the original conditional is if P then Q, then the converse is always flipping the antecedent and the consequent. That's if Q then P. The inverse is taking the original conditional and negating its antecedent and consequent. And the contrapositive is a little bit of everything. We flip the original conditional and negate each piece. Okay, so that's the summary. And before we talk about which ones are logically equivalent, why don't we take a look at some practice examples? So let's copy this chart. I have 4 original conditionals. So I'll call this 1, 2, 3, and 4, right? And I'd like to write with you the converse, inverse, and contrapositive of each of these original conditionals in simplest form. In simplest form. Okay? All right, let's do the first one together. So the converse of this original conditional would be interchanging the antecedent and consequent. So it would be if not W, then T. The inverse is negating the original antecedent and the original consequent and forming the conditional. But this piece can be simplified because we did prove this on the very first logic lesson, that when we take the double negation of a statement, it's logically equivalent to the original statement. So we call this the law of double negation. It's a very simple truth table. And in the same way, the contrapositive would be flipping each, negating each, and forming a conditional. And in the same way as in the inverse case, the double negation of W is W. In fact, we could have gotten this answer directly from this one by just taking its converse. All right, so take a minute and try the next 3. Pause the video and see if you can simplify the next 3. All right, let's try the next one. So the converse of the second one would be if, wrong color again. If P, then not M. Okay, let's do let's go through this. The inverse would be the double negation of P, of M. If the double negation of M, then P, which simplifies into if M, then... Oh, I forgot to negate the P. If M, then not P. And then, of course, the contrapositive would be the converse of the inverse, which would be if not P, then M. All right. Now, the next 2 are trickier because either the antecedent or the consequent are a conjunction or disjunction. So let's look at the third one. So the converse would be if B or C, and that has to be in parentheses because now that's the new antecedent, then A. The inverse would be if not A, then the negation of B or C. But remember DeMorgan's laws, if we want to negate a disjunction, we take the negation of the disjuncts and form a conjunction out of the disjunction. So I'm going to put this in parentheses because that is the consequent, and this is our answer in simplest form. And then finally, the contrapositive would be the converse of the inverse. So I'm just going to recopy that and flip it. Okay, similarly, the converse for number 4 would be if M, then G and W, where the G and W is in parentheses. The inverse would be the negation of G and W. If the negation of G and W, then the negation of M, which can be simplified into, by DeMorgan's laws, the negation of G or the negation of W, and that must be in parentheses, if that, then not M. And then finally, the last one would be the converse of this previous answer. So that would be if not M, then not G or not W. All right, let's go on. Let's practice writing the converse, inverse, and contrapositive of this conditional statement, which is on your worksheet number 16. It is 9E. And the original statement, I wrote it here anyway, is roses are not red if violets are not blue. Now, looking at that statement, it's a conditional. We have the word if, but it's not in that traditional if-then form. So before we start writing the converse, inverse, and contrapositive, we have to write this statement in the equivalent if-then form. So let's do that. Okay, so if something, then something. So the antecedent for this statement looks like violets are not blue. So I'm going to write it here. Violets are not blue. Because it's understood that whatever's after the if should be the antecedent, and there's nothing else after it. And the consequent must have been everything else, even though the then is not explicitly written. So the consequent is, then roses are not red. Okay, so keeping that in mind, we're ready to write the converse, inverse, and contrapositive in the if-then format. Remember, they're each conditionals. So take a minute and do that. All right, so let's check our work. So the converse would be just interchanging the consequent and antecedent of the original. So that should say, if roses are not red, then violets are not blue. The inverse would take the original and negate its antecedent and consequent, but we have a double negative because we're negating the not. So the double negation becomes positive. So the inverse would be, if violets are blue, then roses are red. And the contrapositive would be, if roses are red, then violets are blue. Okay, let's try one that's a little more complicated. Okay, the next two problems are also on your sheet. Under exercise number 12, we're going to do parts E and I. The instructions are the same, except again, we might have to use other laws, like especially DeMorgan's laws, to simplify. So here are the original statements. 12E is, if a whole number is prime and even, it is equal to 2. And 12I is, if x is less than 2 or x greater than or equal to 5, then x is not equal to 4. Notice in these two problems, this antecedent has a conjunction, and this antecedent in 12I has a disjunction, or. The then is not written in 12E, but it's implied. I could write it in here. The comma implies the then. Okay, so keeping that in mind, the antecedent of the original, and it's very important to know which one's the antecedent, a whole number is prime and even, and the consequent is it is equal to 2. In 12I, the antecedent is this disjunction, x less than 2 or x greater than or equal to 5. And the consequent is just x not equal to 4. All right. So I'd like you to write the converse, inverse, and contrapositive of these. Okay, let's check 12e. So the converse would be if it is equal to 2, then a whole number is prime and even. Well, we could make that flow a little nicer and say if the number is equal to 2, then it is a whole number which is prime and even. But I think this is fine. The inverse would be if a whole number is not prime or even. Note that, oh, I did make a mistake here. It should say not prime or not even. Okay, I forgot to negate this. So let's just rewrite this. Or not even, right. Because we have to negate each and change the and to an or. That's very important. So if a whole number is not prime or not even, using DeMorgan's laws, then it is not equal to 2. Okay, and the contrapositive would be if it is not equal to 2, then the whole number is not prime or not even. So let's correct that. Or not even. So again, don't forget to negate each disjunct and change the and to an or. Okay, these are following the rules of logic and the laws that we've discussed. All right, let's do number 12. All right, so let's take a look at this one. I liked it because it had math in it. So the original, we know. The converse is just like the original, except we flip the antecedent and the consequent. I'll leave that up to you to look at. But it's the inverse and the contrapositive where we have to negate. So the negation of this statement would be if x is not less than 2. Well, if x is not less than 2, in math, we could just say x greater than or equal to 2, okay? But that greater than and equals has to be included because that is considered the complementary or negation. The or becomes an and this is the and then the negation of x is not greater than or equal to 5 would be x is less than 5. Okay, so that would be considered the negation of the inequality. And then, of course, when we negate x not equal to 4, that means x equals 4. That is, again, that double negation logical equivalence that we proved, but we don't write it out here. And then, of course, the contrapositive is just the converse of the inverse. So it's if x is equal to 4, then x is greater than or equal to 2, and x is less than 5, which is interchanging the original and negating each piece. And the last one I wanted to do is on the sheet. It's the very last problem, which I considered the most difficult. We want to write the converse, inverse, and contrapositive of each of these, of this particular conditional, but this entails everything: a conjunction, a disjunction, a negation, everything that we've learned so far. So pause the video and write the converse, inverse, and contrapositive in simplest form. Okay, here I've completed it for you. So the converse is easy. We just flip. The inverse, I wrote this one out. I didn't want to do it in my head. So I negated the consequent and the antecedent and the consequent. I wrote it this way. And then using DeMorgan's laws, the and becomes or, and the or becomes and then we have to negate each piece. So we double negate P, which becomes P. We negate Q, which is here. We double negate S, which becomes S, and then we negate T. And note the position of the parentheses. We've got to put parentheses, otherwise we won't be sure what's the antecedent and the consequent. And then finally, once we get through the inverse, the contrapositive is easy, rather than looking at it from the beginning. So we just flip the inverse, and there's our contrapositive. Okay, so that takes care of how to write the converse, inverse, and contrapositive of a statement. Okay, now the big question is, which of these conditionals, which of these pairs, because we've got 4 altogether, are logically equivalent? And I rewrote the answers to the do now. So, and I like this analogy because we could relate to it. So if we say, if Charlie is a horse, then Charlie has 4 legs. All right, say that is true. Which other statement must be true? If Charlie has 4 legs, then Charlie is a horse? Well, that's not necessarily true because Charlie could be a cat or a dog. So we see that the original would definitely not be logically equivalent to the converse. In fact, we proved that the conditional is not commutative. So the original cannot be logically equivalent to its converse. We did prove that already. So the original is not logically equivalent to the converse. So what is it logically equivalent to? Well, it has to be the inverse or the contrapositive. Which one do you think it is? Let's look at the inverse. If Charlie is not a horse, then Charlie does not have 4 legs. All right, now would that always be true? If Charlie is not a horse, then Charlie definitely does not have 4 legs? I would tend to say no. I could think of counterexamples here. Like, what would be an animal that is not a horse and does have 4 legs? Or we could say even a spider. I mean, that's the only one thing that could come to my mind. Okay, a spider's not a horse and it has 8 legs, I think. All right, so I don't think the inverse would do it either. But let's look at the contrapositive. If Charlie does not have 4 legs, then Charlie is not a horse. Well, I would tend to say, yeah, that seems to be true to me. Because if Charlie doesn't have 4 legs, then it couldn't be a horse. Because horses have 4 legs. So I would tend to think that the original statement is logically equivalent to the contrapositive. As far as the converse of and inverse are concerned, well, that's questionable. I think the best way to do this is in a truth table. So let's do that on the next page. Okay, so here I set up a big truth table, which is problem 6 on your worksheet. So you don't really need to recopy this. You could do this directly on the sheet. In fact, I think it's better if you do. And notice how I built up the truth table. I didn't build it up exactly like the sheet. I did it a little differently, but I think it's good for you to see that it doesn't matter what your columns are as long as you end up with the same result. But we all start with a P and Q column. I mean, that's a must. And I figured that we could consider if P then Q, and then if Q then P, that's a converse. Then we have to negate the P's and the Q's, and then look at the inverse, not P, if not P, then not Q, and then the contrapositive, if not Q, then not P. So we all begin, and as I said, I emphasize this, true, true, false, false, and true, false, true, false. And let's just recall when a conditional is false. A conditional is false when its antecedent is true and its consequent is false. So that's what we're going to look for. And I'm going to draw lines here to make it easier, even though the lines are drawn on your chart there. And the whole idea behind a truth table is to look at the column that could help you get the truth values of the subsequent column. Okay, so take a minute and fill in this truth table and let's see what we get. Okay, so here is the truth table completed. I put all the false statements in red and all the true statements in blue. So make sure that the false statements are exactly where I have them here in the truth table. And again, I first focused in when the conditional is false. So if P then Q is false here, oh, let me put that in red because just to be consistent. It's false here, okay? The antecedent's true, the consequent is false. But when we go in the reverse order, the false falls here. Now, we negate the P and we negate the Q column. That's easy. But now we look at these two columns and we see that if not P, then not Q is false in the third row, whereas if not Q, then not P is false in the second row. So let's take a look at what statements are logically equivalent. Well, it looks like to me that the original conditional, because that's what we're really interested, the original conditional is logically equivalent to its contrapositive. And not only that, but we've got something else out of that. The converse is logically equivalent to its inverse. The converse of a conditional is logically equivalent to the inverse of the conditional. And because we proved these using a truth table, we can call these theorems or laws even. So let's write this down. This is a very, very important statement. Theorem. The conditional is logically equivalent to its contrapositive. And we use this fact a great deal when we want to prove theorems in advanced mathematics. Sometimes it's easier to prove the contrapositive than it is to prove the conditional. This is called the law of the contrapositive. And theorems in mathematics are laws. And we will be using that a lot in our logic proofs. And the law of the contrapositive says exactly what we have up there. But symbolically we write, if P then Q is logically equivalent to if not Q, then not P. Okay, very important law. I would say of all the laws in math, I think this one is one of the top three. Okay. But we also proved that, okay, I'll write this down. The converse of a conditional is logically equivalent to its inverse, to the inverse of that conditional. So that would say, now that doesn't have a law, but I'll explain why in a minute. So this says that I should start with the positive one. That says if Q then P is logically equivalent to if not P then not Q. Do you see something really special here? If this was the original conditional, if Q then P, what is this statement to this original conditional? It's the contrapositive. If not P, then not Q is the contrapositive to if Q, then P. So we could have proven this by using the law of the contrapositive. If the original conditional is if Q then P, then the contrapositive is flip and negate, and they're logically equivalent by the law of the contrapositive. So we did a little bit too much. All we had to show is that the conditional is logically equivalent to its contrapositive, and from there we could see that the converse is logically equivalent to the inverse, or vice versa. All right. And before I go on, I wanted to inquire about one thing. We know how to negate a disjunction. We know how to negate a disjunction. What would be the negation of a conditional? Yeah, the negation of the conditional is not usually asked, but it's a nice enrichment. Well, let's say the conditional is true. The only way to make it false is if P is true and the consequent is false. And it turns out that these two should be logically equivalent. Let's try it in a truth table really quickly. And here we've made the truth table really quickly. I've made a truth table for the conditional, negated it, negated the Q, and then formed the conjunction between these two, right? And remember, a conjunction is true only when both conjuncts are true. So that only occurs on this line here. And we see that these two are indeed logically equivalent. So this is something we don't usually do when we write essays, but in mathematics, the negation of a conditional is a conjunction, and it's exactly this conjunction. So suppose I have this problem. Suppose the original question was, negate this. So if the original question was, if it is cloudy, then I will not go outside, and we want to negate this, then we would say, okay, we have to identify the P. The P is, it is cloudy, and the Q is, I will not go outside. So we take the P, it is cloudy. It's not the negation of a conditional is not a conditional. And I will negate the consequent. Then I will go outside. So that would be the negation. All right, let's try negating this one symbolically. So if the original was if P, then disjunction Q, not R, then the negation would be P. We keep the antecedent. We put the conjunction there, but now we have to negate the consequent. But again, with DeMorgan's laws, we have to write not Q and R. And here again, we have DeMorgan's laws and the law of double negation. And that concludes the lesson. So let's summarize what we've done today. We looked at a conditional and looked at three special conditionals formed from every conditional. And that's the converse, the inverse, and the contrapositive. And we proved that the original conditional is logically equivalent to its contrapositive. I mean, that is the highlight of the lesson. And we also talked about what the negation of a conditional would be, since we talked about the negation of a conjunction and a disjunction. And that isn't it's not used very often, but I thought that I would show you that. Okay, and it turns out that the negation of a conditional comes out to be a conjunction. It's the conjunction of the original antecedent and the negation of its consequent. And we practiced two problems with that. Okay, so that concludes today's lesson, and I wish you a wonderful day. Take care.